Hello and welcome to Unit 2 Part 1. I'm Mr. Bell and today we're going to talk about domain and range. We're going to decide if a set of points or a graph represents a function. Before we jump into these examples, I want to talk about two vocabulary words real fast. First one is the domain. Okay? The domain of a function is just a fancy word for all of the x values. And don't forget that every point that's represented as a coordinate consists of an x value and a y value. The x will be on the left, the y on the right. It's in alphabetical order to kind of help you remember. The range is a fancy word for all of the y values of my data set. With that being said, let's take a look at these examples. First one says, does the following set of points represent a function? Well, here's how you know if it does or if it does not. You look at the domain. You look at the x values. If any of the x values repeat, it is not a function. So let's take a look at this particular problem. So we have got a 2, a 3, a 3, and a 4 in the domain. Well, you may notice that the 3's repeat. This is an example of not a function. Okay, looking at the second problem, it says, does the following set of points represent a function? Let's take a look at all the members of the domain. Don't worry about the range. For determining whether or not it's a function, you don't even look at the y values. We have 8, a 6, a 4, and a 2. Well, no member of the domain repeated, so yes, this one is a function. On this slide, you'll notice that we're given graphs instead of sets of points to look at. Now, later on, I'll teach you how to find and identify the domain and range from a graph, but for now, all we're doing is we're looking to see if these are functions or not. And there's something called the vertical line test. Basically, anywhere on the graph, if you draw a vertical line through the graph and it only touches, when I say the graph, I'm not talking about the coordinate plane, I'm talking about the image that's drawn on it. If it intersects it only once, then it is a function. So let's take a look at this first one on the left. No matter where I put an imaginary vertical line, it's only going to touch that image one time. So this one is a function. If you take a look at the second one here, if I draw a vertical line straight up and down, I touch it once, I touch it twice. In this case, this one is not a function. And the last one, no matter where on the graph I draw a vertical line, it only hits it one time on that particular vertical line. So the third example here is also a function. This last example is the same concept, but just worded a little different. It says, consider the following set of points. We've got 2, 5, 3, 9, 4, 13, and 5, 17. It says, if the following point, we're looking at one problem at a time, was added to the set, decide if the new set would be a function or not a function. So let's take a look at what we have above here. And we're only going to look at the members of the domain. So we have a 2, a 3, a 4, and a 5. If we added this point to that set, we would have a -2 also. And none of them repeat, so it would still be a function if we added that particular point. Look at the second one. If we added this point, 4, 21, well, remember from my original set, there was already a 4 in the domain, and now we're doing another 4, so a member of the domain, an x value repeated, and that's a no-no for a function. So this one would make the set of points not a function. And the last example is 0, 9. If you look back at your domain, 2, 3, 4, and 5, and a 0 that's being added, none of the domain repeat. So this third one is a function. All right, thanks for watching and hope this helps.